Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, you will be understanding the lecture 3-2, that is friction definitions. As you know, in previous lecture, that is lecture 3-1, you have learned the basic concepts of friction, limiting friction, types of friction and laws of friction. And in today's class, you will be focusing on the important definitions of friction, that is coefficient of friction, angle of friction and angle of repose, of course, lastly cone of friction. Now, let us discuss in detail about all these four subtopics of friction definitions, and this is very much useful in your end examinations, especially for short answer questions. Now, let us start discussing the first topic, that is coefficient of friction. Let me take this particular block, that is coefficient of friction. Usually the symbol used for coefficient of friction is mu, and small f also is being used. So these are the two standard symbols of coefficient of friction. Let us consider a block resting on the horizontal plane. A block is resting on the horizontal plane, and let us represent it by this hatching and draw the free body diagram. The weight is acting vertically downwards, and normal force, the normal force exerted by the support on the block is N, and let us say force P is acting to the right. The external force, applied force is P, and against to this the friction force is acting exactly in opposite direction. And let me use a symbol, it is F max, which is known as the limiting friction, the maximum possible frictional force. This is the free body diagram of a block resting on the horizontal plane, and Coulomb's, he has conducted number of experiments, and he has published in 1781 his results of various experiments. His results he has analyzed by changing the normal force, and he has observed that the frictional force is proportional to normal force. And as you know that if you write sigma Fy, normal force is equals to W, that means you are going on changing the weight of the block. You are going on changing the weight of the block, and by means of that the normal force is also going on changing, and this normal force and frictional force, these two are linearly proportional, and this has been concluded, or it is done, the experiment done by Coulomb's, and it is published in 1781. So according to that, let me draw the plot. Let me take along the x-axis normal force, and along the y-axis it is frictional force. And if you look at this, you can observe carefully here, the plots are like this. I am drawing a straight line with the more slope. This is for static friction. That means the body is at equilibrium position. And another plot with less slope, this is kinetic friction. So these are the two plots obtained by Coulomb's in his experiments, and it's clearly stated that you can write down now the frictional force. Here it is, this is what is exactly the frictional force, and let me write it is the frictional force is or F max, that is limiting friction, is proportional to the normal force between the support and the block. And if you want to remove this proportional constant, it is F max is equals to, it is mu times the normal force, and mu is equals to, it is F max divided by, it is N and here let me take this mu as mu s. So, F max is a limiting friction and mu s stands for coefficient of friction when it is static condition. Similarly, you can obtain the relation between mu kinetic also. It is F divided by N. Here this frictional force is simply it becomes a few F kinetic friction, and you can take it as Fk stands for kinetic frictional force, or simply F you can make use. So, you can conclude that from this analysis that the coefficient of friction, that is mu, is the ratio of the frictional force, that is the limiting friction, divided by the normal force existing between the two bodies. And this concept is very much useful to calculate the frictional forces. So, that is the first topic of today's discussion. And the second topic is angle of friction. Let me take this particular slot. It is angle of friction. Here the angle of friction, usually the standard symbol is phi. Angle of friction is phi, and let us draw. Here let us refer this figure, the same figure, and let us represent the resultant of normal force and frictional force by means of a single force. I am drawing a line, and at an angle phi, let me call this angle is phi with normal, and this force is R. R is the resultant of normal and F max. So, that means you are replacing these two forces by a single force. That is what is the resultant of normal and frictional force. And if you let us redraw these three forces, that is the two component forces. Here this force is vertical force, and the resultant force, let me take this component is the frictional force, and the resultant of these two, let me use another color, red color, this is R, and of course this is N, and this is F max, and angle between these two is phi. Phi is the angle of friction corresponding to limiting friction. Now, from this triangle you can write down what is tan phi. It is tan phi is equals to opposite is F max divided by adjacent is N, and we know that this expression, just refer back this, it is nothing but mu s. So, here it is phi is equals to tan inverse of, it is mu, that is coefficient of friction. If it is static, you can make use of that static value of the coefficient of friction, otherwise it is kinetic coefficient of friction. So, this is the angle of friction. The angle of friction is nothing but it is tan inverse of mu. So, here you can conclude this angle of friction is you can have static angle of friction as well as kinetic angle of friction. The moment you take that it is static angle of friction, phi s is equals to, it is tan inverse of mu s corresponding to static angle of friction, and kinetic angle of friction is also, you can take tan inverse of mu kinetic, where the coefficient of friction is the kinetic coefficient of friction. This what is your second topic, angle of friction. The angle of friction is nothing but it is the angle between the resultant of normal and frictional force and the normal force. The angle between these two, normal force and the resultant of normal and frictional force, is called angle of friction, and the symbol used is a standard symbol, of course it is phi. Now, let us continue to discuss the third topic, that is angle of repose. So, let me take this particular box to analyze this. It is angle of repose. To explain this, to understand this particular concept, let me take a simple diagram. Let us look at this. I am considering, let us look at this, a block is resting on the horizontal plane, and I would like to change the angle of inclination of the inclined plane. I am increasing the slope. Let us observe carefully. at certain angle, the block will be tending to move down the inclined plane. I hope you understood this particular concept. There is no external force is acting. As you are going on changing the angle of inclination with respect to the horizontal, at certain angle, the block will be tending to move down the plane, and that particular angle is called angle of repose. That is what is the angle of repose. And let me draw the diagram. Let us take this horizontal plane, and at an angle, I am calling this angle is alpha, at which the body is tending to move down the plane. So here let me take parallel to the inclined plane and perpendicular to the inclined plane, and of course weight is acting downwards. Let me take this is W. Let me write it is W. W is acting downwards, and this is alpha, and this is also alpha. And let us draw the free body diagram of this. To draw the free body diagram, let us it is the impending motion is down the plane. So I am indicating by dashed line, that is x is down the plane. So when the block is tending to move down the plane, frictional force is opposite to the direction, that is F max is acting vertically upwards. This is what is your F max, limiting angle of, that means you are considering that impending motion of the block down the plane. So that is F max, and perpendicular to the contact surface, that is normal force, and the component of the weight perpendicular to the inclined plane, this becomes W cos alpha, and the component of the force weight along the parallel to the inclined plane, that is the W sin alpha. Now you have divided the W which is acting vertically downwards. One component is perpendicular to the inclined plane, the other component is parallel to the inclined plane. Now let us consider the notation. It is parallel to the inclined plane is your x-axis, and perpendicular to inclined plane is y-axis. So with respect to this particular notation, let us write down the equations of equilibrium. So let us write down what is sigma fx is equals to 0. Sum of the forces along the inclined plane. See that F max is positive, pointing up the incline. So let me write F max which is positive, and the force component, that is W sin alpha, it is acting opposite to the, that means down the incline, that becomes negative. It is a W sin alpha is equals to 0. There are only two forces, and you can write down F max is equals to W times it is sin alpha. Call this as equation 1, and write down sigma Fy is equals to 0, sum of all the forces perpendicular to the inclined plane, and upwards is positive, N is positive, force N is positive, and the weight component W sin alpha which is acting downwards, that is minus, it is the W cos alpha is equals to 0, and the normal force N is equals to W cos alpha. This is equation 2. Write down equation 1 divided by 2. It is F max divided by N is equals to, W gets cancelled, and you have sin alpha divided by cos alpha, and which is tan alpha. What is F max by N? From this, it is F max by N is it is angle. You can write down it is F max by N is tan phi. So it is tan phi is equals to tan alpha, where phi is limiting angle of friction, alpha is angle of repose, the angle made by the inclined plane with respect to the horizontal. So here you can conclude that alpha is equals to phi. When this alpha, that is inclined plane angle, equal to the limiting angle of friction, the body will have impending motion down the incline. So this is what exactly the condition for the angle of repose. So your as it reaches this angle alpha, which is equals to phi, the body will be tending to move down the plane, and that is what is called angle of repose. And lastly, let us discuss the cone of friction. The cone of friction you can discuss. Let us cone of friction. For this, let us consider the block diagram. I am again redrawing that block. Of course, I am interested in frictional normal force, that is N, frictional force, that is F max. Of course, it is subjected to force P and weight W you have, and the resultant, let me take another color. I am taking it as red color R, which is at an angle phi. And assume that the block is, when it is tending to move to the right, this is the resultant. Imagine that the block is subjected to external force in 360 degrees. When it is subjected to 360 degrees, obviously what happens here, this is a line inclined with the angle phi, and the locus of this line forms a cone. So the locus of the line, if you represent this, and this is a cone, and this is what is called cone of friction. And when it is static, you can use symbol, it is phi subscript s, that stands for static cone of friction. Similarly, you have kinetic cone of friction. That is weight W, and when it is kinetic cone of friction, obviously what happens, this angle will be, frictional force will be less and angle will be less. So it is a normal N. Of course, you have to write this is F, only F are kinetic, it is in motion. And I am using a green color for R, which is making the angle phi, let me subscript is K, phi K. Phi K is the kinetic angle of friction. And similar concept, when the block is moving to the right, it is the resultant, or is the resultant, and assume that the block is subjected to motion in 360 degrees. So the locus of this inclined line, as it moves in 360 degrees, a cone is generated, and that particular cone is called, it is a cone of friction, and that cone of friction is kinetic. So here this is a static cone of friction, and the other side it is a kinetic cone of friction, and observe carefully here, the phi s is greater than phi k, where phi s is static cone of limiting angle of friction, and this is kinetic, that means the body is in motion. I have used it as F max for static, I have used Fk, the frictional force is corresponding to motion. And let me conclude today's class by reviewing once again what we have discussed. We have understood that the coefficient of friction, what is coefficient of friction, by means of Coulomb's experiments. Now we have, it is the frictional force is proportional to normal force, and we have got the expression for the coefficient of friction, and you have static and kinetic coefficient of friction. Angle of friction, the angle made by the resultant of normal and friction with respect to the normal is called angle of friction, and again you have static as well as the kinetic angle of friction. And the angle of repose, the angle of the inclined plane with respect to the horizontal at which the body is having impending motion down the plane is called angle of repose, and we got the expression for the angle of repose is equals to the limiting angle of friction by means of equations of equilibrium. And finally, we have understood that the cone of friction, static cone of friction as well as kinetic cone of friction, and assuming that the block will be subjected to load, that is external force P in 360 degrees, and the locus of this resultant in 360 degrees forms a cone, and that is known as cone of friction. Thank you very much for watching this video.